a lot of other deposition technologies that are not plasma deposition technologies, okay? But you can also do ion implantation, right? Okay, so, or, you know, implantation, right? So I create another category, okay, which would be implantation. Okay, so I created a second category called implementation technologies. Okay?
Sapphire glasses. Sapphire.
Yeah, okay, so actually now so now we realize, okay, well actually that's not the only competing technology, that's just the competing those are the competing process technologies. Okay, right? Not the competing actual technologies of what goes in the glass, for example. Okay, all right. I go, oh, I need a new component here. Okay, so what I'm going to do is I'm going to create a new category here under competing technologies, and I'm going to call them process technologies.
Excuse me, what is the project about?
Oh, yeah.
It's about covering of solar glasses.
Of what?
Solar glasses, like so it's a cover glass for, I mean, started out with like space applications.
To strengthen the surface of our solar glasses.
Yeah.
Yeah.
But also, like, you know, and then also like one has to think about implantation, right? Because, for example, to make the glass harder, it's not just a coating. Sometimes it's actually putting other atoms into the glass, okay? And one way to do this is implantation, okay? You give high energy atoms, okay? You bombard the surface and they have enough energy not just to coat, to stick to the surface, but to actually go in and knock out another atom and replace that atom, okay? So we have deposition technologies and we have implementation technologies, but we realize, oh, wait a minute, those are actually a category called process technologies. So really what I want to do is I want to do I want to split it up into process technologies, right? So I'm going to put my deposition technology under process technology, okay? And I'm going to put my implementation category under process technologies, right? Because really, I have, you know, quite a bit of other competing technologies, right? Because I have the competing technologies that relate to the composition of the glass. Okay, so, right? So that's like another category, right? And I can put all sorts of stuff underneath that, right? So you can always, you know, rearrange that as long as you observe the rule of not mixing categories and components. Now we don't have any components yet, okay? So let's create a component, okay? So I'm going to create a new component under deposition technologies, and I'm going to call it chemical vapor deposition. Okay? Okay, so this is going to be a little bit different for you guys, but again, you know, the interface will be very obvious, right? So I'm going to modify this now. So now here is and it's going to be, again, the interface will be a little different, a little bit more convenient and so on, but functionally it's going to be the same, right? So now I'm going to have. We'll get back to the uncertainty in a minute, okay? So let's say I have found something out about chemical vapor deposition, okay? In the space that I care about, right? So what have I found out about the chemical vapor deposition?
We could sputtering some elements, some different elements.
Okay, but sputtering is not chemical vapor deposition.
Not.
Okay, well, so fine, good enough, okay, so we'll get back to that later, right? So, okay, sputtering. Okay, now, sputtering may also become an entire category at some point, but you know, that's when you have to start to transfer this information, you rename the category and you go deeper and deeper, okay? As you build up your universe. So, okay, so what did you find out about sputtering technologies as a competing technology?
We have all the samples.
Oh, okay, yeah, great. So, yeah, but I mean, tell me something about what you actually...
Maybe Larissa
Yeah, tell me something about the actual sputtering technology.
About sputtering.
Do you have, let's say, do you have a reference? All right, okay, I'll tell you what. I'll tell you what we'll do. This goes a little bit into the second part, okay, but let me try to do something first quickly.
Silicon, titanium, and so on.
First of all, we must to pure the glass with two methods, or with plasma or with
Magnetron.
No, so what we want to do right now is we want to look at sputtering as a competing technology, okay, right? And let's say we do some research on this, right? So this is going into the MIT library system. I'm just going into the MIT library system. Okay, so this is called the Web of Science. I'm going to go into more detail in the afternoon about how to use this, okay? So let's see. Sputtering. What else? I mean, what are we looking for in terms of keywords for the actual deposition or the actual coding or the actual application?
Sputtering of metals and oxides of metals.
Okay, which ones? Give me, just for an example, just give me one metal oxide that's useful.
Message, magnetron.
Which one?
Low and high energy magnetron.
Okay, yeah, but I mean, like, give me a chemical composition, like which oxide specifically?
Titanium.
Titanium oxide.
Silicon, yeah.
Okay.
Titanium and silicon and copper.
Okay, so just titanium or?
And silicon.
Titanium, silicon, okay. Okay, there's more advanced searches, Boolean searches you can do. Again, this is just for illustration, okay? Okay, fine. So I get 1,113 references, okay, of scientific papers, okay? Let's suppose, you know, I do the first one. I'm just gonna pick one, okay, right? Which is the potential of titanium-doped, hydrogenated amorphous silicon films with suitable resistivity and high TCR for whatever, okay, right? So let's just say I use this one, right? Now, this is generally something that through the university library system, okay, and there's an extension I want to do, but it's future development, okay? But I'm just going to tell you that anyway, because it might be a useful piece of information. But you know, it's going to take some programming to figure out how to link this. There is something called, on these kind of articles, there's something called a DOI. Okay, you sometimes see this on the internet, like if you have a document, it you know, has a DOI number. Okay, I forgot what it stands for, but what this number is that this number, so you know, like web pages can change on the internet, right? If a reference is, you know, a certain type of quality reference, okay, it may not just be scientific papers, you know, although they pretty much all have that, okay, but also like industry reports or things like that, right? They have a DOI number, which is basically the permanent way of finding it on the internet. So it might be the case that the web pages change and whatever, okay, but there is a central database in, I think, Canada, okay, that basically tracks, you know, those sort of changes. So you can always reference it with a DOI number, okay? It's permanent no matter how you know, web pages or whatever change, okay? So even if this journal gets bought by another journal or something like that, the DOI numbers are going to be accessible. So in this case, we're not going to use that because I don't have that yet. So, but we don't, generally it's not a good idea if you're in a database that you only have access to from the university or something, right? Then your teammate can't access that, okay, because they don't have the privileges, right? Yeah. Now, you may share the article some other way, but you know, in terms of recording it for the moment, you don't want to use this internet address, okay, web of knowledge, because, you know, when somebody who doesn't have that access, okay, because it needs to be authorized through the university library, then they will not really be able to call on that. So I would encourage you to go to the original, so, which in this case, the journal is called Vacuum, okay, It's volume 119, you know, page 32 through 33 from September 2015. Okay, so it's the most recent article. Okay, so I guess it's from yesterday, or no, today. It was published today, since it's the 1st of September, right? Okay, so let's use this one and do this properly. Now, actually, there should usually be a link in this case. That's okay. Volume 119, issue. Oh, they don't have issues. Okay. That should, anyway, it should get us there, right? Right. So this is, you know, this would be sort of the address from the actual publisher. Okay. In this case, one page 30 through 33. What was it called again? These are not in order. Let's see. Okay, so is this the one we wanted? Well, let's just suppose, you know, let's just suppose this is the one we want. Okay.
Almost the same.
May not be the one. It doesn't matter. Okay. So copy this and oops. So okay, so now I have my reference, right? Now, obviously I've read this reference, okay? What am I going to do? It's just not just a matter of saying like, oh, there it is, I've read it, okay, and here's just the information. It's a matter of like digesting this information of how it relates to your innovation process, okay? So what we're going to do, we're going to edit this in a minute, right? So I'm just going to say my summary, right? And then I'm going to edit this in a moment, and then something else, right? So I want to create a link to that, so I can. So the way this one works is like you position the cursor at the point where you want to insert the reference, right? And then you click Add New Reference. Again, your interface will be a little bit different. So there's a choice of two. One is a web reference, one is a text reference. Okay. So in this case, it's in a web reference. Okay, I put in my web reference and I add the reference. Okay. It tells me, in this case, this might be a little bit different. You know, like I edited at position 1, right? So, and here's one thing you see, like this. As I type things here, oops. What just happened? Sorry, I have to go back. This is because this was a version that was running on top of the MITx thing, and you know that has its limitations. So now we lost that information. See, this is why this. This will not be the case with your thing. This was because there was a constraint of running this on there, and it's not the right architecture and so on. Anyway, but it looks the same. So, what did we have? Competing technologies, deposition. Oh, process technologies. Okay. See, the problem, like with this, you know, hopefully this will work. But the thing is, like, I don't have like with this one, I don't have control over the specific platform. I had to put it on top of it, and then this is too advanced already on top of this platform. So when they change something, I have no control over this. So but your platform is totally different. Like that's I programmed this from scratch. Like so. But summary. So I add a new reference. So let's see if this happens again. Okay, so that's fine. Actually, no, it's the other way around. So now I want to. So I've added the reference number 1. What? Why does it do that? I didn't touch anything. See, this is the problem. I haven't actually I've abandoned this specific platform, right? Because I knew they're going to do something that this would happen, right? So that's why I started to write my own total platform. Okay. Anyway, but I can show you in another way. So what happens? Okay, is So in yours, so you add. Okay, so I'll just show it to you this way. That's fine. So this is a different. This is actually. Yeah.
You have access to such system only until leaving on the cars?
Yeah. Well, at the moment, but we'll have to see. Since I have control over the platform. We have to see how to do that. But generally, I mean, the idea is obviously if you go forward and talk with RBC and whatever, and then obviously going forward will be very useful, right? So, here's a lot of competing technologies, production, whatever, So here, okay, so in this case, so what you do is you write your research summary, okay, and you record it the way I've shown you, right? You look at this, okay, and it just basically it links all the references, right? Okay, so in your universe, it shows you all the summary, okay, that you compose, okay. So what I want to talk about briefly is a couple of things. So the uncertainty that you assign. So there's 3 things that you do with a component. Okay. A, you give it a summary. Okay. B, you give it references, and you embed these references in the way I've shown you, like web links. They will be linked into the text. Okay. And then there's also text references that you can add that don't necessarily have, let's say you make a phone call to industry, right? That doesn't have a web reference, right? So you just want to make some notes about that phone call, okay? Then you click text reference, right? And what that does is it still creates a web reference, okay? But it creates a web reference, a new web page, with that text that you type, okay? That's only linked to your project in your database. Okay, make sense? Right? So you can do things over the web, okay, at the moment, and you can do your own text references. Okay? What isn't there yet, but in the future, but again, all this stuff takes time, is uploading your own documents. Okay? But that's a little tricky in terms of what kind of documents and so on, so you have to get that through some process. So you create the text reference, you create and you have a number of references, okay, in one description, right? You can have a description of a component, you can have 20, well, maybe not 20, but you have 3 references in there, okay? So you were looking into sputtering, okay? And it starts out as a component. You're going to say, oh, I found these 2 references, okay, they're pretty close, okay? They're both about sputtering titanium, okay? And you say, the first reference says that important information that you take away from it, okay, is you want to record what? You want to record, let's say, in terms of their experimental results, okay, maybe they have a thickness okay, or maybe they have a surface roughness or something, okay, whatever it is that you're interested in, okay. It's not about summarizing the entire article, okay, but it's a matter of summarizing the relevant information at this time, okay, for your innovation process, okay. That's step number one of what you should sort of put in the summary and where you got it from. Okay, so you can always go back, and every one of your team members can go back and saying like, ah, okay, I can look at this article, right, or I can look at this resource, right, I can read it myself, and maybe I'm going to like think about it a little bit differently, okay. That's between team members. But the reality is, okay, and this is where it becomes very, again, going forward, okay, once you keep accumulating this, right, in half a year from now, you don't really exactly know what you've read, right? And especially if you have like 500 different references, right? Okay, so not only do you want to go back and be able to look at that reference again, because you might have a new piece of information. Remember how Gene was talking about, there's other pieces of information that come in, right? And you realize, oh yeah, there was something else in that reference that I completely ignored because I didn't think it was relevant, okay? And you can go to it, you can find it very easily, okay? The second thing that you want to record, okay, in those research summaries, okay, is how you relate it to your innovation process, okay? How you relate it to your innovation process, okay? And this is where you want to be very short and concise, but especially intellectually honest, right? Meaning don't draw conclusions, sort of at this point, okay, but say like, oh, I'm thinking this, but I'm not sure about that, okay? Or I've only looked at the abstract, or whatever, like it's not a matter of like handing something in, okay? This is primarily for you as the innovator, okay? So that you can come back in half a year or a year when it's time to revisit this component, because obviously things have changed and so on, that you can say like, what was I thinking at that time?